Chapter 7 begins the largest concept of AP statistics. 40% of the AP exam will be on the next few chapters. We're going to start with sampling distributions and to really look at how data falls when we're taking samples. So let's do a quick review on the difference between a population and a sample. Take a moment to read through example A and see if you can identify what the population and the sample are. It can often be difficult to find the population especially. So just remember the population has to be the group that we're taking the sample from. Don't worry about extra information or things outside of the sample. In this problem, you can kind of tell where the population is because we're choosing 2% of the artifacts at random. We've selected those to check the student's work, and these are the artifacts that have been found. It's not all the artifacts that haven't been found, so you want to be really careful with how you word your population because we're doing a random sample from the artifacts that were found, and that leads to what our sample is. So these are the 2% of found artifacts randomly selected. So be careful with your population, especially that you're only talking about what we're taking the sample from. So a common mistake here would be students saying that it's all of the artifacts at this dig, whether they've been found or not, and that's not true. We're taking 2% of what we found that have been classified, assigned, and then we're taking 2% of them to check the student's work. I'd like you to go ahead and try example B on your own. Let me know what you think the population and the sample are here. So I think the population was pretty easy to find. We want to know about the 45,000 people who made credit card purchases. The sample is the tricky part. It's only the 137 survey forms that were returned, not the entire 1,000 people who were selected, because we don't have anything to work with if they didn't return the form. Let's get into two new definitions, first being parameters and how do we denote them. So first, I've already got the definition there. Parameters are any measurements of the population. And what's lovely about this is it's easy to distinguish this. P starts with for parameter and P for population. So you know that those two go together. And our notation, how do we denote them? You're already familiar with this. We use mu for mean, and we use sigma for standard deviation. Now you'll learn the difference between the different symbols I've been using so far. I've kind of talked about it before, but now it's really important you know the difference between the two. So what are statistics? These are any measurements of any sample I would take from the population. And once again, what's really neat about this, statistics, sample, both start with the letter S. And what are the ways we denote them? We're going to bring back X bar. This is the mean of the sample, and S, and sometimes we denote that by S of X, is our sample standard deviation. When we take a sample, we don't expect that single sample to exactly match the parameters of the population. And even when we take repeated samples over and over, we don't expect them to even match each other. So the repeated samples are going to vary either large amounts or maybe they're very close to your actual population. And they're also going to vary from each other. So all of that change from the actual population is what we call sampling variability. In these graphs, you can see a visualization of our population and our samples, and then actually looking at a sampling distribution. So putting all of that variability together in a graph. So here, right here, this is what our population looks like. So it's saying that our population of whatever we're measuring here, I don't even know what it is, but exactly half of these widgets are blue and exactly half are red. And then we do a sample. So here's one single sample of 20 widgets. It looks like there were 200 to start with. And then our first sample, we ended up with quite a few more blue than we did red. I'm going to introduce a new symbol here to you. So we've got P and what we call P hat. You've been exposed to Y hat before. So this is now our predicted value. It's a lot like the mean. So let's go back up to our population and parameters and our samples and statistics. A new symbol for you is P. So just P is a parameter, and P stands for proportion. It's very much like mean, but where mean is an actual number. Notice we didn't look at the number of blue or red widgets. We're looking at a proportion. So now this makes a little bit more sense. The P is the proportion of successes. So if we're looking for red widgets and not blue ones, that's what I'm measuring here. Then the statistic is going to be the P hat. That's our proportion of successes in a sample. So this is going back to our binomial and geometric distributions, mostly binomial. We're looking for that proportion of success. So we have to have those two events. So either my red happens or nothing else. It wouldn't matter how many different colors I'm given. I'm just looking for that one success, which in this case would be red. So let's go back to our graphs. Here we've got two examples of two different samples, but we're actually going to do, let's see if it ever says, I don't think it does say how many samples we're taking here, but it looks like quite a few. I'd say it's almost 200 samples maybe, because each one of these represents a dot. So it's either 100 to 200, but this is just showing you a graph of two of those many, 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 many samples. So in the first sample we took, we only had 8 red. In the next sample we took, we had 11, and then we did this many more times and came up with this graph. And you can see that sometimes it went as low as, I guess that would be 0.15, and as high as 0.8, but we know that our true proportion was 0.5. We can see quite a few of our samples were exactly the same, and we can see what the shape of this distribution is. Now, got a question for you guys. This distribution is looking pretty what? Hopefully you said normal, and this is true, but there has to be some things in place before we can see for sure whether this is normal. And we're going to be exploring those in just a moment. So what's the difference between the distribution of the population and the distribution of the sample? And the sampling distribution of a sample statistic? That's a mouthful. I think this answer will clear up what they're asking. The distribution of the population and the sample displays the two possible outcomes. So this is the population here. We can just see the two possible outcomes. So this is the true parameter, the true data. But then our sample shows slightly different data, and but it still shows the two possible outcomes. The sampling distribution shows all the variation in those successes, those looking for the red, from the repeated samples. So we can see all the different, so it's kind of like taking 100 of these graphs, deciding what we consider a success, and only displaying that information and all of its variation from the true proportion.